Yes or no? Why cannot? Are the four tips of the wings on the circle? No, they are not. You see, one of them is at the center. So can you use angle in the same segment? Cannot. What is the reason we should be using for this? What is the relationship between x and 30? X and 30, what is the relationship? Hello, angle. X and 30. Angle x and angle 30, are they the same? They are not the same because by the converse of angles in the same segment. You see, angles in the same segment, they must be equal, right? Today, they are not in the same segment, so they cannot be equal. Get it? Yeah, got parallel lines, but we will come to that later. I want you to focus on x and 30. What is the relationship? Times 2. Which one times 2 equals to which one? 30 times 2 equals x. So x equals to 2 times of 30. What is the reason? Why should x be double of 30? Angle x equals to 2 times of angle ACB. What is the reason? Okay, angle at center equals to 2 angles at circumference. Okay, so 60 degrees. We actually went through the derivation, how we get all these reasons. Angle at center is 2 times angle at circumference already. So x being 60, how then do we find y this time? What other angle can I find? CBO. CBO. I hope you all are seeing why we are trying to find angle CBO. Because again, what is so unique about this question that forces it to look like this? What are the qualities of that? Parallel lines, right? The parallel lines force an angle y over there to appear. So you definitely need to use something about parallel lines. And angle CBO is the same as angle x. Over here, angle CBO equals to angle EOA, which is x 60 degrees. But what is the reason? Alternate angles, parallel lines. Yes, this is what we expect to see. So since this is 60 degrees, what can we do now? What else can we do? 60 plus 30 equals to y. What is the reason? Huh? No. Kevin says that angle 30 plus 60 is angle y. What is the reason? Exterior angle or triangle? Exterior angle or triangle? Remember these two interior angles? You add them up, then you get an exterior angle over here. Not many people actually do it this way, but it works. Normally, other people will do angle CEB is 180 minus 30 minus 60. Then you get 90. Angles on a triangle. Then after you get 180 minus the 90, you get another 90 adjacent angles on a straight line. Okay? I show you the longer method. So if you didn't want to memorize exterior angle or triangle, fine. We can do it anyway. So angle CEB, 180 degrees, minus 30, minus 60, angle sum of triangle. So angle Y must be 180 minus 90 degrees. Adjacent angles on a straight line. Done. Okay? Any more help required? If not, we are moving on already. Okay, we're now at chapter 10.3. Okay, well, please watch my drawing over here. Here I have a circle. I'm not going to tell you where the center is because it doesn't matter. We're going to derive, just as we did last lesson, we're going to find out some other relationship or some other angles. If I have 2 points over here, A, let's say this one B. I randomly selected these points. Then I join them up to have. Okay, like that can? Let's call this point C lah. So here I have an angle ACB. Okay, so far? Yes. Very random, right? I'm going to draw from point A to a random point over here D. Do you think this angle over here is related to this angle? Are they related? Yes. Why? No. Why? Why? I don't teach you this way. I never ever tell you because the textbook say so. We want to give them understand why. So some of your friends say, yeah, there's a relationship, but they don't know why. So why? In the first place, are they really related? I randomly choose a point D, right? So if D is not at that point, for example, if let's say D is over here, let's call this D1 and D2. Okay, I'm going to join A to D2. Oops. Okay, A join to D2, D2 join to B. Do you think this angle over here, let's call it theta 1 and theta 2, then this one we call it alpha. Do you think theta 1 and theta 2 look similar? Yes. Look only. Do they look similar? Yes. Yeah, they look similar to me. It's not like both one is acute, one is obtuse, reflex, whatever. They both have the same shape. Now, if you were to do an accurate drawing, you realize that they're all the same. Whether D1 or D2 or maybe over here D3, you will get the same theta 1, theta 2, theta 3. They're same. But the question is why? Why? Any suggestions of what we can do? Find a relationship between these two. How? Suggestions? What have we learned so far? Angles in the same segment, angles in a semicircle. Any more or not? Angle at center is 2 times angle at the circumference. Maybe let's try that. Let's put this as the center. O. Okay? Let's join these two together. A to O. Then O to B. I haven't changed anything so far, right? I just introduced the center and I join A to O, O to B. Okay? Now, tell me what is, if this one over here is alpha, how much is this? Okay, reason? Angle in center is 2 times angle at the circumference. Okay, good. What about, just now we said this was theta, right? How about this angle? Is it 2 theta? Why not? Okay, this is 360 degrees minus 2 alpha. But is it related to theta as well? Yes. What is the relationship? 2 theta. This is equal to 2 theta. But why? What is the reason? Same thing. Angle at center is equal to angle at 2 angle at circumference. So let me draw it out for you this way. This is the angle at the circumference. This is the angle at the center. If this is theta, this is 2 theta. It's the same reason. Angle at center, 2 angle at circumference. We are not so used to this this drawing over here, but we are very used to this one. Okay, theta, then 2 theta. But these two have the same relationship. Can? Okay, now back to this. So we say that hey, this is 360 minus 2 alpha because angles at a point. At the same time, it is also equal to 2 theta, right? So what's the relationship between theta and alpha? Is there a relationship between theta and alpha? Yes. What is the relationship now? Minus 2 alpha equals to 2 theta, right? Divide by 2. Okay, divide by 2. 180 degrees minus alpha equals to theta. What else?
Then theta plus alpha equals 180.
Ah, magic. Okay, this is... Now we can remove all this already. Because the center, right, we introduced it ourselves. It didn't have to be there. But we saw that by considering the center, by considering our angle at center is 2 angle at circumference, we end up with this relationship. Hey, theta plus alpha is actually 180 degrees. Okay? This is applicable for a 4-sided figure inside a circle. Mathematically, we call it a cyclic quadrilateral. You don't need to know the name. It's a quadrilateral 4-sided figure inside a circle. So cyclic quadrilateral. Or we can call it a quadrilateral inscribed. INSCRIBED. It is inscribed inside a circle. Alright? So as long as you see a quadrilateral, 4 points, the 4 vertices touching the circumference of a circle, I can use this relationship which says that the angles in the opposite, what word should I come up with? Theta and alpha. Opposite what? Circumference? No. Segment? Opposite segment? Why will it work? Where are the segments? Okay, draw a line AB. If I draw a line AB, can you see 2 segments? Okay, there is a segment with theta, there is a minor segment, there is a major segment containing alpha. So alpha and theta, they are angles in opposite segments. And they will add up to be 180 degrees. This is the next thing that we have just discovered. Angles in opposite segment. For theta and alpha. Now, we're going to remove these two. What is the relationship between angle A and angle B? What is the relationship? Angle A and angle B. A plus B equal to 180. Reason? Angles in opposite segment. Okay? Change the question. Now watch. What is the relationship between theta and alpha? What's the relationship between theta and alpha?
They add up to 180.
What is the reason?
Because angles in opposite segment.
Really? Is theta considered an angle in a segment? Yes. Whenever we use the phrase angle in segment, it must always touch the circumference. For example, like this, angles in same segment must touch the circumference. Right? Similarly over here, angles in opposite segment. Does that angle over there, theta, does it touch the circumference? No, it doesn't. So there is no limitation. I could have drawn it like this, and I'll get a different angle. I can draw it like this, and I'll get a different angle. So if you have a question like this, it can't be done. It is ambiguous. Okay? So this one, no answer. Ambiguous. Not confirmed, not clear, not specific. Okay? Okay, next. If I have a circle, okay, class, watch. I'm going to draw a tangent line. a tangent line to a circle. Okay? So the tangent line only touches at one point only. And can you all see exactly where it is? You're right. And if this is the center, O, let's call this point A. What can you tell me about OA, the length OA? Must be the radius, okay. What can you tell me about angle let's call this B and C. What can you tell me about angle OAB? 90 or why? I got teach, man? By what? By logic. What logic is this? Why is it that you all are saying that OAB is 90 degrees?
And OA is perpendicular to BAC.
Why? Why? Why is OA perpendicular? Wait, one by one. Yes, sir. Okay, yeah, it touches at one point, so. Yes, what's it?
Example is like weight, right? Ball touches the floor, then you will touch it, then the weight just accelerates.
So it's a neutral equation.
Weight will go straight down, then the floor is straight, right? It's perpendicular.
It's neutral, so it doesn't overlap.
Why? Yeah, I know it's horizontal, but why is it so straight? It's
Because due to weight, it goes.
yes, okay. Tangent. Yeah, only touching one time. Then can't it be like this? Can't I say that this is the circle? Then this can't this be 80 degrees? Why cannot? Why it must be 90?
Because you are the center of gravity.
Common sense, you're finding it very hard to describe, right? Let me tell you, let me make you feel more comfortable. Do you think a ball resting on a flat surface with the diagram like this, do you think it is symmetrical?
Yes.
All can agree, right? All can agree it's symmetrical, right? If it is symmetrical, what is this angle over here? 180. If it is symmetrical, then what must this be? 90 lor. Is there any part of my explanation that you don't believe, you disagree with? This one I purposely I didn't draw it symmetrical lah. Okay, so the reason is that it is by symmetry. I like your responses. You all talk about center of gravity, weight pointing vertically downwards, uneven ground. How? You mean like that? This kind of ground, is it? Then it's no longer a tangent, ma? If it is a slope, then this point will be the tangent. This will be my 90 degrees. Okay? Then the weight of the ball is like this. So it will start to roll down this way. Because it wants to reach equilibrium at the bottom right. The CG wants to be as slow as possible. But it's not physics, so I'm not talking about all this. Yes, Racy. Okay, wait. So, Racy, you're saying that because it is a tangent line, and if you tilt a bit, then what? From the center, tangent line only touch one point, I agree, yes? If you connect it to a point that it is touching, it will be the radius, okay, I agree. I say it's radius, so it must be 90. What's the reason for that? Uh-huh. I tilt a bit already. Tilt the radius, is it? Radius not touching tangent line. So meaning like for example like this? Then what? So which one is not 90? The tilde one is, you mean this one is not perpendicular to what? Risi, continue. You're saying that this radius is not perpendicular to the tangent because it doesn't touch in the first place, right? Okay, then. For it to touch, it must be a perpendicular tangent line. If it doesn't touch, then it is not a tangent line in the first place. Oh. Okay. I need to think through what you just mentioned. Because you're trying to tell me why it is perpendicular, is it? Please can I see me later. I want to discuss about it. Okay? Hey, don't run away. These are all useful. Okay, next. So we just discovered something else. It is called tangent perpendicular to radius. So class, every time you see a circle, I draw a radius, I draw a tangent line. You will automatically tell me that this is 90 degrees already. Okay? So here, let's call it theta. Theta equals to 90 degrees. And we say that tangent TAN, perpendicular to radius. Short and sweet. Yeah, you can do this lah. You know, all this stuff. Okay, one last part. Since Avril was talking about AMATs like this. Okay, so this one 90 degrees, right? 90 degrees, yes. What is the reason? No, you say? Tangent, perpendicular, radius. Okay, that's the reason. This will be R. I'm going to draw another tangent line. Oh, okay, that's horrible. Okay, here I have another tangent line. It touches at this point, right? Okay. I don't want this one. Change. Okay, over here. So I've got another tangent line. This is R. Agree? What is this angle? Reason? Tangent, perpendicular, radius. That's it. If I join this side, the center, to this point over here, let's call this an exterior point. Is it a reasonable name? Exterior point? How many triangles do you see? We got 3. Okay, 2 triangles. What can you tell me about these 2 triangles? They are symmetrical. They are same. In maths, what do we call it? Congruent. Prove it. Prove it, alright. You say they are congruent. You say these 2 triangles are congruent. Prove it. Okay. So let's call this point A, B, and C. Okay, you talk to your partner. How do you prove that these 2 triangles are congruent? Recap on the board. We've got S, A, S, A, S, A, S, R, H, S. Wait. Talk to your partners first, then we talk about it. Okay, done? How many of you say SSS? No. Cannot be right. Didn't even give you any length, right? No. ASA? No. SAS? No. SAS? Yes. Okay, wait. What's so special about SAS? What's so special about SAS? You know the order, does the order matter? It matters only for one of them. This one. The rest of them, order does not matter. You can call this the same as AAS or SAA. Doesn't matter. You can even call this SHR, but nobody does that. Nobody does that. This one you can call it SSS or SSS. You get my idea, but this one cannot. What is so special about the A? A must be included. So it is like this, angle A over here. Must be included in the side 1 and side number 2. Okay? So with this revision, can I use SAS? No. Cannot. Those who say can, convince yourself. Can or cannot? No. It cannot. Last one. Can?
They have the same hypotenuse.
Ah, okay. We have a right angle already. And you are telling me they have the same hypotenuse, is it? How will you say it? OC equals to OC. Reason? Common side. So I've got right angle. So the R is settled already. I've got a hypotenuse. What about the side? Where's the side? AO, BO, same. Because radius. Therefore, these two triangles are congruent. Now that we have proven that these two triangles are congruent, what can you now tell me about? Okay, what can you tell me about AC and BC? So we do all the proving, proof. Triangle OAC congruent to triangle OBC. We proved that they are congruent already. What can you tell me about AC versus BC? Same. Okay, if you say they are the same, what is the reason? Why Pythagoras theorem? Okay, yeah, you're right, can. But I want you to use what was proven earlier on. Yes, Pythagoras theorem can show you that these two are equal, but what can we use from our two triangles that were proven to be congruent? If the two triangles are congruent, what about the sides? Corresponding sides must be the same. Okay? So here we say that AC is equal to BC. Reason, corresponding sides of congruent triangle. Okay? Besides AC and BC are the same. Take note, if you recall how we proved this, the question did not tell you that AC equals to BC. Question only give you two tangent line, one exterior point, one external point, exterior, external, whatever, doesn't matter. We'll just shorten it to EXT. Okay, one external point. There is a circle, radius, so on and so forth. We found that they are congruent, therefore we conclude that AC and BC are the same. What else can we conclude from this triangle? These two triangles. Something that was not given in the original question. Okay, all the angles are the same. Which one? The right angle quite obvious, right? What other angles are the same? Angle AOC equals angle BOC. So here and here, they are the same, right? Reason? Corresponding angles of congruent triangles. Okay, what else do we have? BCO. ACO, BCO. Okay, reason? Again, corresponding angles of congruent triangles. Therefore, anytime you see this diagram, you want to call out any of these three reasons. Okay, not reasons. Listen, listen. As long as you see this diagram, the question did not tell you that AC equal to BC. Right? They didn't tell you that, but now you know they are equal. Similarly, AOC and BOC. Question did not say, but now you know they are equal. And finally, ACO and BCO are the same. Question didn't tell you, but you know. You knew these three because they are proven to be congruent triangles because of the RHS congruency test. Anytime you want to use these results, you call out one reason can already. These three, they have a reason. It is called tangents from ext point. Okay? You do not have to prove that triangles are congruent, therefore this, that, this and that. As long as you see this diagram, you know straight away these two must be the same length because it's the radius. You know that this must be equal to this because tangents from exterior points. You know that these two angles must be the same. Reason, tangents from exterior point. You finally know that these two angles must also be the same. Reason, tangents from exterior point. Yes? Okay, wait. So this angle, let's call it theta. You're saying that theta is equal to? ACB equal to this angle over here, let's call it alpha, plus, why? So the claim only. The claim is that theta equals to alpha plus 180 degrees. True or false? Okay, why? What's the reason? Okay, then tell me about the math lah.
ABS.
Okay, listen. Do you all believe him? Okay, come, son, let's try. Wait. 360 minus 90 minus AOB minus angle AOB, then equal angle ACB. Okay, then 360 minus 90 minus 90 is 180 lah. Wait, how do you go from this step to this step? Minus AOB? Oh, separate. Okay, this is equation number 1. 360 minus AOB. Okay. Then make what the subject? What? Where got? Okay, angle AOB equals to 360 minus reflex AOB. Okay, then sub this one inside here, is it? Okay, then I sub in, I'll get 180 minus 360 minus reflex AOB equals to ACB. Therefore, reflex AOB equals to angle ACB plus 180. Okay, proven. Okay, so it is true. He found another relationship. What this means is that I can set for test paper. We can. You see, these are, all your textbook questions, right? Prove that angle is equal to this angle, show that this one is that one. We are all trying to find relationships. And here we have another relationship which is not that difficult to prove. There is another way lah. Yeah, it's recorded. Okay, based on his first equation, we actually can get it already. 360 minus 90. So I get 180 minus angle AOB equals to angle ACB, right? Then we are trying to find theta, which is 180 minus AOB. 360. So 180 degrees minus, this is 360 minus reflex AOB is ACB. So actually from one equation we could have gotten it already lah. So reflex AOB is ACB plus 180. Okay, so this is equivalent to what he was saying. So we are not going to call this a law lah, because there are many relationships that we can have.
So then what can you, what makes it a law?
What makes it a law?
Or like what makes it a Pythagorean